Hello everyone. Today I'm going to discuss about the topic called nanoelectronics. Nanoelectronics is basically a theory topic, but we need to discuss it as it is a very important topic. So let's start. Firstly, we'll see the outline. Outlines are nothing but the headlines. So the first one is what is nanoscale? What is nanoelectronics? Why nanoelectronics? History, advantages, industrial applications, materials, nanotechnology in electronics, nanotechnology in India, problems, future nanoelectronics, conclusion, and then there comes references. Okay, so let's start with our first slide. What is nanoscale? Nanoscale क्या होता है? चलिए देखते हैं क्या होता है. फर्स्ट वन इज नैनो मीन्स ड्वार्फ इन ग्रीक. ड्वार्फ बेसिकली मीन्स स्मॉल और टाइनी, दैट इज नैनो. ओके. सेकेंड इज 1 billionth of a meter. It is 1 billionth of a meter. Then 1 nanometer equal to 10 raised to power negative 9 meter. Then it is used to measure nano electronic devices. Okay. Then here I place a image of nanoscale. As you can see, I make a round circle. This is basically a nanoscale. Alright. So let's move on to the next slide. What is nanoelectronics? First point is art and science of manipulating matter at the nanoscale. Okay. Then one of the major technologies of nanotechnology, it plays a vital role in the field of engineering and electronics, makes use of scientific methods at atomic scale for developing the nanomachines. Its main target is to reduce the size, risk factor, and surface areas of the materials and molecules. Then last point is it is implied to be used as the next generation approach towards manufacture of MEMS, microprocessors, optical switching, and several other electric components. So basically nanoelectronics क्या होता है? Nanoelectronics एक टेक्नोलॉजी है जो कि यूज़ होती है टू रिड्यूस द साइज, सरफेस एरिया, किसका, कंपोनेंट का, मटेरियल्स का या मॉलिक्यूल्स का रिड्यूस करने के लिए. ओके. दिस इज इट्स मेन टारगेट. सो दिस इज all about nano electronics, and then there comes the image about nano electronics. Then why nano electronics? First point is today microelectronics used and solves most problems. Then nanoelectronic devices are very small devices, yes, and overcome limits on scalability. Nanoelectronics is not only about size but also phenomena, mechanism, etc. Wide open field with vast potential for breakthroughs coming from fundamental research. It overcome two demerits. First one is physical size and second is cost of IC fabrication. That is why we use nanoelectronics, to overcome the two demerits, that is physical size and cost of IC fabrication. Okay, next one is history. History seems to be very important. Okay, so let's discuss it. The first ever concept was presented in 1959 by the famous professor of physics Dr. Richard P. Feynman. Intention of scanning tunneling microscope in 1981 and the discovery of fullerene, that is C60, in 1985 lead to emergence of nanotechnology. The term nanotechnology had been coined by Norio Taniguchi in 1974. The early 2000s also saw the beginnings of commercial applications of nanotechnology, although these were limited to bulk application of nanomaterials. Okay. Then the last point is the number of transistors on a chip will approximately double every 18 to 24 months. That is Moore's law. It basically gives the law that the transistors become double after 18 to 24 months. Okay, this is Moore's law. This law has given chip designers idea to incorporate new features on ICs. So this is all about the history. Then there comes the advantages. These are some of the advantages of nanoelectronics. I'm gonna discuss it. Reduced size and scale of the machine. This is the first advantage. Okay. Second is advanced properties of semiconductors can be determined. Third is extreme fabrication also supports the multiple use of single machine. Parallel processing is also empowered by nanoelectronics. Then fourth is increasing process variability and expected physical and reliability limitations of devices and interconnects. Then there comes it is used to produce smaller and faster components. Computers consume less energy. Yes, it's a very important advantage. Computers consume less energy. Then high speed and high capacity memory. Then there comes interface and system integration technologies on a single chip and integration of different types of chips and devices in a single package. And the last one is allows circuit to be more accurate on the atomic level. These are the advantages. The next is industrial applications. Industrial applications means that what are the uses of the nanoelectronics in the field of industry. So let's see. The technology made the devices very light, making the product easy to carry or move, and at the same time it has reduced the power requirement. Then some consumer products which are using nanotechnology. First one is computer hardware, then display devices, mobile and communication products, auto products, camera and films, then electronics example, that is example of electronics, single electron transistors, controlled electron tunneling to amplify current, resonance tunneling device. Then fourth is quantum device used to control current. Then there comes the materials used in nano electronics. Okay, first one is zinc oxide, that is dirt repellent. It is dirt repellent, hydrophobic, cosmetics. Zinc oxide is basically the first image you can see in this way. This is the image of zinc oxide. First one. Silver ion. Second, silver ion. It has the healing property. Then the third one is aluminium silicate. It has scratch resistance. Then gold ion, chip fabrication and also drug delivery. इसलिए यूज होता है gold ion. Okay. These are the materials used in nano electronics. Then nanotechnology in electronics. Electrodes made from nanowires enable flat panel displays to be flexible as well as thinner than current panel displays. Yes, as we can see in our daily life that the displays are becoming thinner and thinner day by day as there comes advanced technologies. Okay, so second point is nanolithography is used for fabrication of chips. Then the transistors are made of nanowires that are assembled on glass or thin films of flexible plastic. Then e-paper displays on sunglasses and map on car windshields. Then a memoristor can be used as a single component memory cell in an integrated circuit. Then the last one is magnetic nanowires made of an alloy of iron and nickel are being used to create dense memory devices. Alright, nanotechnology in India. Let's see. First point is IIT Mumbai is the premier organization in the field of nanotechnology. Second, research in the field of health, environment, medicines are still on. The main objective of nano mission are: first is basic research promotion, second is infrastructure development for carrying out front making research, third is development of nanotechnologies and their applications, human resource development, and fifth is international collaborations. As you can see in this image, the use of nanotechnology is higher in Tamil Nadu. Okay, then there comes Gujarat, then Karnataka, then other states. Alright, so here comes the problems. First is quantum and coherence effects, high electric fields creating avalanche dielectric breakdowns, heat dissipation problems in closely packed structures, as well as the non-uniformity of dopant atoms and the relevance of single atom defects are all roadblocks along the current road of miniaturization. Okay, this is the first problem. Second one is carrier mobility decreases as channel length decrease and vertical electric field increase. चैनल लेंथ जैसे जैसे डिक्रीज करती जाएगी वैसे वैसे कैरियर मोबिलिटी भी डिक्रीज करती जाएगी और वर्टिकल इलेक्ट्रिक फील्ड जो है इंक्रीज करती जाएंगी. ओके, द थर्ड पॉइंट इज wattage/area increases as density increases. Okay, these are some of the problems. Then future nanoelectronics means, what is the future of nanoelectronics? Okay, first is stretchable electronics or flexible electronics is likely to be the future of mobile electronics. Second one is potential applications include wearable electronic devices, biomedical uses, compact portable devices, and robotic devices. Last one is in the future, it is likely that graphene will become a dominant material in flexible electronics. Dominant material means that जिसका प्रभाव बहुत ज़्यादा है. Who is more effective? Okay, that is graphene. Graphene is nothing but an allotrope of carbon that has superb electrical conductivity, flexibility, and physical strength. It has superb electrical conductivity, means good electrical conductivity, flexibility is also good, and physical strength is also good. Okay, this is future nanoelectronics. Then there comes the conclusion. Nanoelectronics show promise as a technology to continue the miniaturization of IC. Then flexibility is also a major breakthrough in this world of electronics, which will enable a new approach in design and functionality for the devices which our modern lives depend upon. Okay, flexible devices have already begun to make their way into the commercial realm, and in the next few years are bound to see huge changes brought on by this additional dimension which is now available to electronic manufacturers. Okay, last point is nanotechnologies also promise a future in development and enhancement of mobile devices and wearable devices. Alright, these are some of the references, so you can have the basic idea or wide discussion about what is nanotechnology and nanoelectronics. If you guys think that I have to improve on something, you can give me some suggestions in the comment section box. So guys, I hope you all like my video. Thank you guys.